Hey guys, I am back for, I think this is 9-5, Integrated Math 2, 9-5, otherwise known as Integrated Math 2, Unit 9, Lesson 5. And this is basically what we're learning for this lesson. Um, I do have the notes over here, if you guys like to have a look at this instead. Um, so yeah, this is basically all we're going to need to know this lesson. Oh, come here, you can take a picture of that, do whatnot with it. But yeah, I have it written down right here though. And now I am going to show you guys some questions. Oh, and then there's also this. Focus. Oh my goodness. This thing has issues focusing. Okay. So if n root of a to the m power is a real number and n is greater than 2, a to the m over n is equal to the nth root of a to the m power, and a to the power of m over n is equal to parentheses nth root of a end parentheses to the m power. That is probably the most confusing thing you're going to hear, but this is basically what it means. Let me zoom in right here. The third root of a is just a to the 1/3 power. And I don't think I wrote that well, so I'm actually going to show you guys a different example. So let's take n to the a over m, right? And I'm going to write down 4 over a squared. This will be our number. And n, which is our root number right here. Oh my gosh. Okay. Right here. It's greater than 2 or equal to 2. Then this number, which is in the form right here, is equal to this form, which would be a to the 2 over 4. And if you want to be technical, that is technically a to the 1/2. These two numbers are equal. Do you see how we sort of rearranged these numbers? That's practically all that is being said with this really long sentence right here. Whenever you see a lot of these variables, it might get confusing. My best advice is to keep track of where it is. Or no, keep track of the variables and where they are. Try to plug numbers in as examples of what those variables could be, like I did here with the 3 in the a and the 4th root of the a squared. Plug the numbers in, it'll probably make more sense. And yeah. And then there's also other things about exponents, which is just this stuff. X to the 0 is 1. X to the mn is just x to the m times n. Xy to the m power is just x to the m power times y to the m power. You're going to need to know also all of this. These are sort of givens if you don't know what they are. Let's say we have x n. I'll actually write examples for all of these. This is basically what it means. The product rule of exponents. To multiply when two bases are the same, these are our bases, here and here. Write the base and add the exponents together. And our exponents are 3 and 5. 3 plus 5 is equal to 8. And that is the product rule of exponents. The quotient rule is more or less the same thing, but reversed. So we'll take our different numbers this time. 2, 6 over the quotient rule of exponents states that to divide when two bases are the same, write the base and subtract the exponents. Right here, these two numbers have a base. They both have bases of 2, right? And the exponent is 6 and 4. And 6 minus 4 is 2. And that's how we get 2 over 2. And then the zero exponent rule of exponents is any base except for 0, where our x would be equal to 0. Any base except for 0 raised to the 0 power is equal to 1. And that is essentially what it means. So x, if this is any number other than 0, if it is raised to the 0 power, it's always going to be 1. Now, the power rule of exponents is a bit more complicated. I'll read it first this time before I write it out. To raise a power to another power, write the base and multiply the exponents. I will show you an example here. So we'll have 3 squared to the 5th, right? So this is our example right here. 3 squared raised to the 5th exponent, kind of like the xmn. This is equal to 3 to the 2 times 5, better known as 3 to the 10th power. So 3 squared to the 5th power is equal to 3 raised to the 2 times 5 power, which is just 3 to the 10th power. And yeah. And then negative rule of exponents. If a factor in the numerator or denominator is moved across the fraction bar, the sign of the exponent is changed. That might get a little confusing. This is basically what it means. Let's see. I'll write down some examples right here. Give me a moment. So I have written my stuff. This is our first one right here. 6 to the negative 3 raised to the negative 3 power is equal to 1 over, or let me start that again. 6 to the negative 3 power is equal to 1 over 6 cubed. And do you see how our sign changed here from negative to positive? Yeah. And then just to show it again, because I showed it right here, 1 over 6 cubed is just 6 raised to the negative 3 power. And yeah. And then for this right here, I actually, I'm not going to lie, I did not know that until just right now. Should probably start paying attention in class. But x over y to the negative n power is just y over x to the n power. Sounds confusing, don't worry about it. 7 over 3 to the negative 4th power is equal to 3 over 7 to the 4th power. So you flip these numbers around and you flip the sign on this exponent, positive to negative and negative to positive, and you get what should be the same answer if you were to completely multiply this out. Anyways, now we start our problems. I'm going to try to zoom in right here so you don't get to see it. Whoa, the quality sucks. Okay, so this, we're going to be doing stuff like that. Now, that's going to look really, 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 it's probably going to look really scary at first. But I want you to know it's not that bad. Anyways, you guys probably just saw the answer, but it's fine. So we're going to write that question out. We're going to pretend like we didn't see that. I'm going to ignore the lines. And we're going to have 4 to the, whoa. I can barely see anything, this damn phone. Okay, hold on. I learned my lesson, and I'm using a pen now. So this is our problem right here. This might look really scary. Don't worry about it. So if we go back over to, I actually don't know where it is. Well, okay, I'll have to explain this in a different way. Because both of the terms in the numerator and denominator, because both of them are raised to the, or not raised, because they're both, you're finding the 4th root of both of these numbers. This number right here, this number right here is equivalent to these numbers. Or no, whatever the answer to this is equivalent to the answer of this. It's kind of, it's like a modified version of like the rational exponents, but also not. It's, I don't know how to explain it. I'm kind of like, I'm having memory loss right now. But just know that these are the same thing. They are only the same thing because the roots are the same. We're finding the 4th root of both terms, which is why this works. If one of these had a 3 rather than a 4 in the little root place, you would not be able to do this. Just want to be clear about that. Anyways, When we move back to this problem, though, like I said, that you're going to look at this and you're probably going to freak out. Don't. Because now this is our new problem. If we take the, the quotient rule of exponents, we can look back over here and see that 2 to the 6th power over 2 to the 4th power is equal to 2 squared. Now let's apply that to these x's. We have x7 over x squared. Both of these are x, so they both have the same base. Now we just do 7 minus 2, which is equal to 5. Therefore, x to the 7th over x squared is x to the 5th power. And now we can simplify this equation to the 4th root of 96x to the 5th power over 3. Now, let's divide 96 by 3. 3. We should know this. It is 32. It's quick math. So now we have the 4th root of 32x 5. This is a lot easier. Now, I don't know if I explained this in the other video, but we are trying to find the 4th root of the numbers inside the radical, meaning that we have to find 4 of the same number and then take it out of the radical. You'll see what I mean in a moment. I might not be explaining this correctly. So we have 8 and 4 for our roots of 32. We have 8 and 4. We have 4 and 2. This one is just 2 and 2. This is 2 and 2. Ew. Okay. And we have 1, 2, 3, 4, 5 4s. We're only going to take out 4 of them. And now our new answer is the 4th root of, what is that? What's left? No. Just the 2. 2x to the 5th with a 2 on the outside because we took out 4 2's because we're finding the 4th root. And now we have this number. Now for x to the 5th, that's just x times x times x times x times x. How many x's do we have? 1, 2, 3, 4, 5. We take out 4 of those x's and we put that x on the outside of the radical. So we have 2x times the 4th root of 2x. We have 1x and 1 2 left over that we cannot simplify farther than this. Yes, you could potentially calculate what the 4th root of 2 is, but I'd rather run a marathon. So this is our answer. I'll do another question, kind of walk you guys through it. This time I'll use a different problem that we have done in class. This is actually just another one of the examples. So our next problem, I will write it out real quick. So what happens when you have a number like this? This probably also going to scare you. Now, remember what I did last problem where I combined these two numbers into this one fraction inside the 4th root? I'm doing the opposite to this question whenever the camera decides it wants to focus. So we can rewrite this problem. We have the 4th root of 48x to the 10th power over the 4th root of y to the 8th. This is our new problem. What's the answer to this? All right. Okay, so looking at this, we can separate both of these terms and do our own equations for them. So let's do the 4th root of y to the 8th power. I'm not going to explain this one too much because I feel like this should be a bit obvious. Y to the 8th power is y multiplied by itself 8 times. So we have 8 y's. In a group of 8 y's, we can take out 2 groups of 4 y's. Therefore, somewhere at the bottom, we're going to have y times y. Because we have the first group of y's, of 4 y's, and then the second group of 4th y's. This is also just y squared. So there you go. Now, in our denominator, we have simplified the 4th root of y to the 8th power as y squared. We're going to leave this right here. We're going to need this later. Put a box around it. Now let's take this monstrosity, 48x to the 10th power. This is also not that bad. So let's write it out where we have space, 48x to the 10th power. And let's deal with our x to the 10th power first. When you have x to the 10th power, you have 10 x's. I don't have any x's. Anyways, you have 10 x's, and you can take out two groups of 4 x's. Therefore, we have x times x. However, 4 times 2 is 8, which is what we got over here, right? And we still have an x squared left over in the radical. I'm just going to write that here because I guess I could write it out. We have x, 2, 3, 4, 5, 6, 7, 8, 9, 10. Right? And we're going to take out 1, 2, 3, 4. And this is our first x. We'll put it in parentheses. And then we have 1, 2, 3, 4. And this is our other x. Now, in the radical, we still have these two other x's, which, spoiler alert, are just going to stay in the radical. Anyways, we have the x and the x now, which is just x squared. And we know that somewhere in our numerator, we're probably going to have, write this bigger, an x squared. That is guaranteed because you can't simplify it. Not that x squared, you can't simplify that. Now we have to deal with our 48. So let's write that over here, fourth root of 48. And let's factor. So we have 16 and 3, we have 2 and 8, then we have 4 and 2, and then 2 and 2. We have 1, 2, 3, 4 2s. So we take out a 2. Now, I'm writing it in the answer box because I already know that you can't simplify this. When you have it when you know that you can take the 2's out, don't write your answer immediately because sometimes you can simplify problems. Like if you had 3x squared. No, that doesn't work. If you had something like 3 plus... Wait, hold on. I'm sorry, I'm losing myself. Okay, 2 plus 4 times the square root of 2 over 2. This can be simplified. You can divide everything by 2, and then you can get 1 plus 2 root 2. Sometimes you can simplify these crazy problems. I don't have an example of that for you guys. I'm so sorry. But you can. I know that for this case you can't, though. So anyways, we have the 2x squared over y squared. Now we need to find what's left in our radical. So first of all, we've already said that our x squared is going to be left in the radical. And after factoring out 48, we see that a 3 is left over. Therefore, our answer should be the fourth root of 3x squared. And so right here we have the fourth root of 3x squared. And this is our answer to our other problem. If you have any questions, feel free to ask me. I think this phone is running out of battery. I'm so sorry. So I'm probably going to only do this one for you guys. But yeah, it's not that hard. If I look at the next lesson, I actually might be able to do it. But yeah, actually there was a whole other something that I forgot to do. It's fine. I'll do that in another video. It's this rule. Don't freak out. This is my example. So we have b to the p over r equals the r root of b to the p, where b is the base, p is the power, and r is the root. This should all probably make sense. And yeah, so here's our first one. Where are my zoom options? Excuse me. There we go. 2 cubed to the 2 over 3 power is just 2 squared. Because, like we have over here, how should I explain this? Okay. This is actually a really bad example. Or 8. Wait, oh yeah, so this is what we did. So we have 8 to the 2/3 power. Rather than doing the entire thing by going a third root of 8 squared, That's too much work. Why would you want to do more work? You're not stupid, right? Right. Okay. We know that 8 is 2 cubed. So we substitute 8 with 2 cubed. And then remember our other rule from this page about the power rule of exponents, how x to the m to the n is just x times m to the n? Well, apply that back over here. 3 times 2/3 is 2. So therefore, this entire equation is just 2 squared, which is 4. And if you were to calculate this, you'd actually get your answer to be 4. But yeah. But now that should mostly be it. I'm sorry for forgetting about that, but I'll see you guys.